Hey everyone, Naveen from Is the Interviews is Coding Interviews channel. So today we are going to discuss about sliding window problem techniques. There are two types of sliding window problems that I have encountered so far. One is fixed window size and the other one is variable window size. So in a fixed window size problems, you are already given the size of the subarray that we are going to be building in our solution on. In today's session, we are going to discuss only on the fixed window size problem. Okay, so we can, first of all, why sliding window? We are asked this problem in the interview, not because we have to implement it at our job. Many companies have internal tools, something like for monitoring system. Some have metrics where they see all the graphs, how much traffic has been coming in at what time. The logging system has sliding window at what time, what was the status of our application of the service. If there are any errors, then engineers can look into those logs. They can use the sliding window and determine at what time they found the error and what was the step before that which caused that error. In system design, when you are designing a rate limiter, one of the techniques you can use is sliding window. Okay, so let's see how sliding window works. With an example question here on Leetcode, which is 643. So you are given an integer array numbers and consisting of n elements and an integer k. Okay. Find a contiguous subarray whose length is equal to k that has the maximum average value and return this value. And any number with a calculation error less than 10 raised to minus 5 will be accepted. Okay. Let's see the example. So we are given the nums array which has positive and negative integers and can be need not to be in a sorted order. And the value of k is 4. So the output is a float value. Okay. So what happened here? Maximum average is 12 minus 5 minus 6, 50 divided by 4, which is going to give you 12.75. Okay. Makes sense. All right. So let's do this. Let's use a rough paper, just in case, so that we can actually look into how the algorithm works, and then we can start working on it. Okay. All right. So we have this problem. I just copied the numbers from the input. So we have 112 minus 5 minus 6, 50 and 3. We have to find a maximum average of 4 elements because the window size is given as 4. Okay. First, when we go into the brute force, what we do is first we start our index from here, and we can keep on increasing our index till we reach the value 4. Index 4, because our k is equal to 4. We calculate the average here, and we see that this is the maximum subarray average so far. Okay, perfect. Next, what we can do is we can start from index, the next index now, and from there we can keep on going for I plus k. That many number of elements we will start including in our subarray, and we calculate the average again here. We compare it with our previous average, and now we finally save our maximum average. We again do the same process by incrementing our index. So we see that we have we reach these number of elements now, and again we calculate the average. We compare it with the maximum and store it in the maximum, whichever is the maximum. We again do the same thing. We increment our index and we keep on incrementing till we build a subarray of size k. But now we know that the index has already reached out of bound of the array index, array length. So which means this is not going to be possible, and we can exit our loop. But what happened here? If we see, we started building our array from index 0 to index 3, right? You calculated the sum. Now again, when you increase the index, you calculated the sum of all these elements, which is you're summing these three elements again. You're duplicating your efforts again in the next iteration for these elements, right? You are duplicating your efforts. So this is going to turn out to be of n square algorithm of n time complexity, right? Space complexity, you are not storing anything extra. You're not allocating any auxiliary space. So it is going to be a constant space. We can do better than the brute force by moving to sliding window strategy. So how we do that? We first build a sliding window. We first build a window of size k. Now we calculate the average value. Let's call it a. Perfect. Now we calculate the average of this window, and now we are done with the first window. Now we are going to increment. We are going to include this element in our window. That means we have increased the size of the window. And since it is more than k, and because we included the right element, we are going to remove the first element from the left. This is not needed because the first element was outside the range. We do not need to calculate it again. And this is the only size of the array that we are interested in. So we calculate the average of this sub-array, and now we are going to compare it with our maximum average. Likewise, we are going to do the same thing. We are going to include this element in our subarray, and we are going to remove the first from the leftmost element from the previous subarray. Now we have this subarray average, and now we have A, B, and C. We can get the maximum of all these, and that's how we will get our maximum subarray. If we have to write this in our code, I'll just go with the Python because every person has their own language of preference, and writing in Python makes it easy for anyone to understand how to write it in either C, C++, or Java. All right. So we have definition, find maximum average, and we have the input nums and the input k. Perfect. Now what we are going to do is we are going to calculate the sum of the first window, this one. Let's call it window sum, which is a sum of first k elements, right, in the nums array. Okay, now we need to get the maximum total, maximum sum, which is going to the first window only, nothing different. Now we are going to start building our sliding window. So we are going to slide the window from k till the last element of nums. All right, sounds good. Now we are going to include our new element, window of sum, from the new element, nums of I, and we are going to remove the leftmost element from this window. And the leftmost value will be at what index? If we don't know how to calculate it, just use this. Suppose right now the value of k is 4, and that means I value will be equal to 4. Since we want to remove the value at index 0, that will be I minus k. So we are going to remove I minus k, and we are going to again calculate our maximum total, which is max of max total and window sum. All right, so we keep on iterating as long as we can build our subarray, and eventually we have to return this. We have calculated the total. Okay, we have to return the average, and the average is of total numbers equal to 4, right? So we are going to divide it by k. Okay, so let's do this. Let's move our code to the Leetcode platform and see how it runs. I'm going to use the same code that we just used. Windows sum is sum of numbers, first k numbers, right? And then max total is the first window for I in range from k to the last element in the nums. All right, now we are going to add the new element to the window, and we are going to remove the old element, the leftmost element, nums of I minus k. We are going to recalculate, reassign the total in maximum total. All right, perfect. And now we are going to return the average value of the max total. Return max total divided by k. And this works. Let's run other test cases that we have already in the example. That also ran. And let's submit the code. And it completed. Perfect. I hope this made sense. If you have any questions, please post it in the comments. I'm definitely going to answer each and every question as much as possible. And next I'm going to cover another problem on fixed size window. And don't forget to like and subscribe. Bye.